Hello, and welcome back. So, we are talking about today, in this new series, a idiom I like to call the idiot method. So, I've actually created this method over my just my whole working career, as well as just kind of lessons I've picked up from my multiple years of developing. I've been developing for the better part of a decade at this point, and the way my brain works is I just tend to find all these patterns and stuff. And I have found a pattern that has worked for me both in the industry and in my personal projects. I am someone that is actually known for being able to complete projects from end to end. And I don't really get hung up on a lot of stuff that most people get hung up on. Don't really know why, but one of the things that's really helped me is by developing this method. And you know, with as with all frameworks, it there are kind of flaws to certain things. There are things that this framework just won't cover. So you do have to take it with a little bit of a grain of salt, but I do tell you, like, this will solve 80% of your problems, especially if you're someone that is just starting out. You have no idea where to start on something. Just know that you can apply this method to your entire project. And it can be really fun to kind of have this kind of a loose structure to it. So I've already mentioned in other videos, I'm not a very highly conscientious person. So if you've taken a disc profile, it will reveal to you if you're kind of this high C kind of a person. So if you've never heard of that, go look it up, DISC. But that just tells you, are you someone that likes a lot of patterns and a lot of tools and stuff? So I personally don't. I'm not someone that just uses a bunch of tools when I'm coding and going about a project, but I've found that this tool is really, really useful for me. Like I say, it allows for a lot of flexibility in how you go about doing a project, but it has a bit of rigorousness that's very easy to implement in just like your frame of thinking about problems. And I encourage you, don't just think about this for your coding problems, but think about this for all general problems. I actually didn't start out problem solving as a coder. I started out problem solving as more of an inventor, someone that tinkered with Raspberry Pis and Arduinos. And so coding was always something I had to do at the end of the day, but it really wasn't the main problem, right? The OS was a part of the problem. Bigger problems were things like soldering this board, figuring out a schema for it, figuring out how to do sketching methods onto PCBs and stuff. So those were much harder problems and much, replication issues and, product supply chains. Like those are things that all can benefit from thinking through with this method. And so don't always just think about, don't really try not to use this for just coding. But if you're having personal life issues that, or just you're trying to develop a habit, or you're trying to kind of do something about yourself or change maybe something in yourself, consider this method. Like, it can really apply to a lot of different things. So without further ado, I just kind of want to do a brief overview of this method, and I'm going to do videos diving into each one of these things. This is more of a talking kind of video. This is really hard to kind of show out code wise, but once again, I'll be doing videos in the future just about me kind of like coding for a couple of hours, and you'll just kind of get to see. I'll call out like, hey, I'm going through the idiot method right now. So, but it's really hard to kind of fashion a good solid example, because honestly, even if I took an hour of your time, it wouldn't be a good demonstration of the idiot method. Like, I really think about this as something that you apply this to something that takes like 2 weeks to do or 1 week to do. Like, it's something that takes a good amount of time to do, and this helps you make sure that you can actually accomplish that goal. So, and other frameworks that people use is something called SMART. So that's a very goal-oriented way of tracking stuff and making sure that you are setting up SMART goals. So that's another one you can go look up and compare against this one, but just kind of setting a realistic goal for yourself. The thing I don't like about SMART as much is that once it just requires that you have experience. So experience is something that's time bound, whereas this is something that my idiot method is not time bound. Like, it doesn't this doesn't really change, like depending on how much more experienced you are, because it just assumes that you don't know anything about the problem space that you're going into, and so it's like that's why it makes room for investigation. So let's go into it. So it is an idiom. It is a it is just a cute little quirky way to remember kind of all these ways. I have it laid out on the screen for you right now, but I actually really like what it ended up, the acronym ended up coming to, because I really am a fan of KISS, keep it simple, stupid. And so I think this is very much in the vein of that, of like, don't overcomplicate your project. Don't try to prescribe to all these crazy methods and stuff. Like even something like test-driven development, sometimes it's just, it overcomplicates the problem. Like the problem that we're trying to solve is not my process of making code. It really isn't. The problem we're really trying to solve is the actual problem itself. Like the thing that we're trying to code a solution to, that is the thing that we should be focusing on at all times. And so our processes should conform around the problem, but we shouldn't really be solving problems in our process as we're trying to solve the actual issue at hand. So that's kind of why I built this method, is because I just saw a lot of code tutorials moving towards how do we make ourselves like really focusing a lot on the coder and focusing on the team and stuff. And I am okay with that. Like I like the idea of the team being on the same page and coding in very similar styles, but it still doesn't really help you solve the problem at the end of the day. Like, say that you spend a year focusing on getting the entire team to speak the same language or choose the same language or get really good at a language. It doesn't really help the client over here that's been waiting for a year for you to build the feature. So, and that's my biggest issue, is that a lot of these other frameworks like test-driven development and all that, it just requires so much changing of the mind gears that it can actually take away and cost money from the organization for people to integrate those policies. So that's why I just want a framework that's very adaptable, and especially if you're very early in your career, it lets you focus on the meat of the problem, and then you can go back later and think about, okay, well, how do I integrate TDD in with the idiot method? So without further ado, let's just do a brief overview of it. And so, like I said, one of the big points about this is just, we're in a coding context here. It's all about figuring out how to get to the end of a project, and just do it as concisely as possible, and do it with the highest quality that we can. So all the time we're balancing quality over the time that it takes, the speed to execute it. And so this method just kind of keeps us on our P's and Q's, and even allows you to be a bit more self-guided. So a lot of times you'll be working on a project and you will not have anyone else looking over your shoulders to make sure that you're doing all the steps and doing everything properly. And in fact, the better you are, the less people looking over your shoulder you'll get. So even when you go to a pull request, likely you'll get the pull request approved just by your status in the organization. Hey, I don't like it, but sometimes that happens. So you have to kind of hold yourself accountable and make sure that, hey, when I code this up, I know that it's meeting a certain level of quality as I go through here. So yeah, this is just kind of why I like following a 5-step process. What I usually see people do is they like to jump right into a project. And I'll kind of talk about just what I usually see with people versus how I believe you should be going through this project. So the first thing, let's just walk through each of the initials in here. So the first one is investigation. And like I said, I'll be doing a bigger video talking about each one of these just individually, but with investigation, high level is just, that is the work to figure out what is the problem that I'm trying to solve. Like how might I go about kind of solving it? Have other people solved this problem already? What kind of problems did they face? Has someone tried to solve it and failed? is this a problem worth trying to solve? Are there better solutions to this problem? So you're thinking through a lot of these kinds of questions. You can really think about this as the fun detective work. So if any of you really like to play detective games and you like to solve puzzles and stuff, this is a lot where you get to work that part of the brain. And I like to leave this very open ended. So one of the biggest things, if you're working on organizations, you'll have these limiters around you. So say if you're versus when you're working on a personal project, you don't have as many limitations. So inside of an organization, inside of a corporation, you'll maybe have a limitation like you have to code this up in C#, or you have to use these internal frameworks. You can't use any external libraries. Maybe you can only use a certain version of a library. So you'll have all of those things. You want to note that in your investigation that, hey, I'm limited in these ways for finding a solution. Whereas on your own personal time, you might say, well, there's this open source project over here that I want to use, and all the licenses match up. Like this might be a very viable solution for me to use. And right then and there, you might have solved your problem and you don't need to move on. So part of the investigation is just figuring out, is this a problem I need to solve? So like I say, I will lay out a lot of those questions for you, but it can be very enlightening going through this step, and it's just a free flow exercise. Go through, understand your problem space, and make sure that you're not trying to reinvent the wheel here. The next thing is going to the design stage. So this makes the fundamental assumption that, okay, you finish your investigation and you realize that there is some work required to bring about this work item. So from your investigation, you don't think that there's any previous solution for this, and so you go about you need to go about implementing this yourself, and you need to start to even think about, how do I sell this to the team? How do I think about this getting prioritized? How do I make sure this doesn't take a lot of time to do? How do I make sure that this solves all the use cases? And so you're thinking about some of those questions, like, prioritization, is this important? But then also, what are going to be all the things that we need to do to implement this out? And so with the design, a lot of people, even here, they get caught up on making the cool UML diagrams and making the cool flow charts of everywhere that data is going. And that's only one part of the design. The other part is really a selling. You're arguing the case that this should be designed this way. This is the fastest way. This will have the quality that we want. And that this is better than any other solutions that are on the market. So don't forget about the argumentation part of it, because it could really, while you're designing it out, you might say, this is going to take me 6 months to implement. I'd rather go back to investigate a little bit more and see if there's some other solution that was already out there. Or maybe in your investigation, you found a solution that wasn't so great, and maybe you have to build upon it a little bit more. And so that is kind of integrated into your design. You can kind of compare designs. You say, well, we can adapt this one, or maybe this was an open source library, so we could contribute to that library. That might take us 3 months of just kind of going back and forth in that community, or we can just build it all by ourselves. We can build a client to handle all these things by ourselves, but that's going to take maybe 4 or 5 months. So design is where you have all this. And of course, design is where a lot of people will have their discussions with their team and tell them some insights. I would totally recommend you at least talk to one person after your investigation. So right before you start designing out stuff, talk to one person, make sure, hey, does this seem right to me? And sometimes investigation is talking to one person. So when you're starting out, usually you're not going to be building out, like if you're a junior dev, you're not building something that's huge and unique and brand new to the company. Usually you're trying to find what technology within the company we should be using for the project. So sometimes investigation is literally just a one-on-one conversation with someone on the team to go like, have you heard of a technology that we might need to be using in this case? Or maybe you're going off to some other team, some sister team, and saying, hey, I heard that you all were working on this. Can I get some more information about that? So that is sometimes all the investigation is. So, and then like I say, so you'll have that one meeting in investigation, and then you'll have another meeting in design where you're getting broader input from the team. Now, sometimes your design meetings jump to a huge org. and you're like, okay, I need a lot of opinions on this. And so that kind of gets into the design. And the next one we have is the implementation. So you've finished design meetings, you've got your diagrams done, and you've prioritized the work, and it's committed. And now it's time for you to sit down, heads down, and jump into the implementation. This is the most fun for most people that are coders. A lot of people actually get anxiety before they get to this point, but once you've made it to this point, it can be very fun to sit down with, maybe for you it's a cup of coffee, a cup of water, and for the next 2, 3, 4 hours, you just code away at the problem because you fully researched the space. You know what APIs to use. Now it's just a problem of coding it all up and getting it all tested and stuff. So this is the meat of it. I'm not going to go really into details on that because, that's just coding. I'll go more into details on that maybe in the video just on implementation, but that should kind of be pretty clear. And the next one is optimization. Now you might be saying, well, isn't optimization a little bit a part of implementation? Well, I wanted to actually call out the next two, optimization and testing, because I don't think that they get paid attention to enough. And so when I was building this framework, I wanted these to be bullet points. Like if you are checklisting through your work, on this, or for a work item, right? For the life cycle of a work item, I really wanted to see that this person paid attention to each one of these bullet points. So with optimization, I really do think that as part of your implementation, you should do a phase of optimization. And what optimization is it can be refactoring. So you could kind of call it optimization / refactoring, where you just say, hey, I coded it up this way for the first iteration, but I actually kind of think that I could switch these classes around a little bit more. I could break these things up a little bit more. And while it doesn't really change the function of the class, it will make it a lot easier to integrate with this thing later. So, and this is a very common phase. Like people in strong devs already naturally do this. So if you're someone that's already gotten into like a very top tech company, you already probably do this step as part of your PR. And so it's totally okay for this to happen inside of the PR, where you're going back and forth with teammates and you all are talking about, oh, you should try to do this, use this library instead of that one, this is faster. So this tends to happen within the pull request process, but I want to call it out for you personally when you're going through a project to make sure that you are implementing this step yourself and just making sure you're thinking through what are ways that I could have refactored this code, what are ways that I can make this faster, cleaner, clear to someone that might come after me. The last one is testing. This one very often neglected, but this is just making sure that you have full testing on this one. You don't have to have 100% code coverage on your code, but you just need to make sure that your code is being tested, that you have tests covering the main use cases of your class, just making sure that it is shielded and protected from changes that will happen for years to come. And that there aren't things that that you should be testing for that you're just not writing tests for. So this is a very, very crucial and vital part of a project. It is often neglected because people say, well, the code works, so I can move on. I've optimized it, I've refactored it, I don't need to write any tests for it. And I've really seen too many code bases that just don't have any unit tests, and they're shipping production code. So you're pretty much moving and iterating in the dark. So, really, this is a huge, important one. It's very much eating the vegetables of working on a project, but it pays off in spades to do this stuff. So just kind of keep that in mind. But yeah, that's pretty much it on the idiot method. I highly encourage you try this out. Like I say, try it out in daily life. I think it'll work and more stuff than you might even imagine. I think even in daily life, people don't write down changes that they want in their lives and they don't make any kind of plan. And it's not saying that you need to have like a very detailed plan. Like in the design stage, especially for me, I don't like to be too specific about how I'm going to design something out. I just like to understand what are the things I can and can't do. And that way, when I'm coding it, it's all ifs and else that are going off, right? So I'm like, oh, I can't do that. I can't limit it by this, or I can't use this API and stuff. So I just, in my design stage, I like to just get all the ifs that are out there. And then when I'm implementing it, I just kind of keep them all in my head. That, that might not work for a lot of people. Some people might want to have a very clear roadmap of how they want to go about something. And so that's why I say, even for a personal goal, think about how you like to map out things with your coding, and then how that might apply to your life. And maybe you can map out things in a very similar way and get input from people and just see if that's a realistic way of going about things. But yeah, I will say, so in my closing thoughts, I'll say some of the things that I think are missing, or some of the things that I most often see people missing when they're going out. The first one is investigation. People very rarely investigate things, and they jump right into the design phase of things. And it's just the fact of the matter is that you have to go out and investigate a little bit. You have to see what's out there. You have to understand the landscape that you're coding for. And this is like, if you're consulting for someone, for instance, you need to ask that person lots and lots of questions and make sure you're building exactly what they want. But no, you can't just, you really can't just jump into the implementation or even the design part of it, and you haven't even talked to the person about what they want. So I see way too many devs jump into the later parts of, especially implementation. A lot of devs just get addicted to the implementation part of it, but it's because it's what we're good at. It's what a lot of us, it's a core to what a lot of us are good at and what we spend time improving on. So, I think about it a lot like soccer. Like I actually didn't play a lot of soccer, but how I think soccer would work is just like, in soccer, you probably practice kicking the ball a lot, right? But you might not practice standing still and looking at someone a lot, when it turns out that, well, standing still and looking at someone might be the majority of what you should be doing. And so that might not seem as fun to do that part of it, but it's essential to make the entire game work. If you're always aimed at trying to hit that ball, you're going to collide with people. You're going to cause all kinds of mayhem on the team. So, that's my limited understanding of soccer. But it's just like that with code. Like, if you just focus on what you're good at and you're always going at it like, I'm just going to implement something for me, and I'm so good at implementing, I'll just fix it if I break something, then you're just going to cause a lot of mayhem on the team. People won't be able to rely on your code. And it works to fix code that only you are working on, but it doesn't work when your code is shipped out and a lot of people are reliant on it. Maybe your code is very hard to fix when it's out in the world, and it's just that you need stronger guarantees for your code once it's implemented. So just spend a little bit more time investigating, talking to people, really understanding the problem space before you jump into the next steps. And then just like that, on the opposite side of it is really testing. I don't see test. No one tests their code. It's a true travesty, and I think it's an epidemic that will. Honestly, I treat it very seriously. Like, it's something that we are getting away with it right now, but it is not something that's sustainable as we move into more serious fields. As we move into autonomous cars and healthcare, we have to have unit tests in place. We have to make sure our code is well tested and that we are very good testers. It's truly an area where I don't think that people are spending any time getting good at. It's very boring. I get it. It's just like investigation. It's not fun. It's not the juice of the project, but it is absolutely where people need to spend more time honing their skills. So if I had to describe kind of the distribution curve of where people spend a lot of their time, it actually really would be something very similar to this. Like it would be probably like something like that for where people spend their time coding. So that or just from what I've observed. So certainly think about trying to implement the I and the T just a little bit more. And I think that that will solve a ton of your code problems and will make you probably one of the best devs on any of your teams. But yeah, we'll be diving into each of these initials in later videos. But yep, this was just an overview of the entire method. Hope to see you in the next videos. Thank you.